In this video, I will explain section 9.6, Calculating with Powers. In this section, we will learn two rules for making calculations with powers. The first one is about a product. If you raise a product to a certain power, then all you have to do is raise both of the factors of that product to that power. The second rule is about division or a fraction. If you divide two numbers by each other and you have to raise that result to a certain power, you can just raise the numerator to that same power and the denominator as well. Here it is important to know that the value of the denominator is not 0, because dividing by 0 is not possible in mathematics. Now, these two rules are being explained in the examples here. You can read them through yourself. I will look at some exercises with you where these rules are used as well. The first one is 44c. Here we see between brackets minus 2ab, which is a product, which we have to raise to the power of 5. So we have to use the first rule here. So everything between the brackets should be raised to the power of 5. So I start with the first factor, minus 2 to the power of 5. Should be written between brackets just for now. Then a to the power of 5, mind the multiplication, and then b to the power of 5. We can write this shorter. Minus 2 to the power of 5 needs to be calculated first. 5 is an odd exponent. That means that this result will become negative. 2 to the power of 5, I believe, is 32. So I get minus 32 here. Then a to the power of 5 times b to the power of 5 can be written behind it without multiplication symbols. So we had to write it without brackets, which is now done. Here another example of a product that needs to be raised to the power of 4. So we're going to raise each individual factor to the power of 4, starting with minus 5. So minus 5 to the power of 4 times x squared to the power of 4. These two should be written between brackets now. And then finally y to the power of 4. Now let's work them out one by one. Minus 5 to the power of 4 is going to be a positive number because now the exponent is an even number. So I just have to calculate 5 to the power of 4, which I believe is 625. Then we need to raise x squared to the power of 4. And whenever we need to raise a power to another power, we can multiply the exponents by each other. So this will become x to the power of 8. Now, times y to the power of 4, that's already in its final stage. All I can do now to write it shorter is remove the multiplication dots and just stick it all together. This should be the final answer. In exercise 45c, we get a division or a fraction, both are the same thing, that needs to be raised to the power of 5. So both the numerator and the denominator are going to be raised to the power of 5. That's easy. For the numerator, that's just q to the power of 5. For the denominator, I have to raise 4p to the power of 5 to the power of 5. So here in the denominator, I get another example of a product raising to a power. So let's look at that again. Copy the numerator. So 4 needs to be raised to the power of 5, and p to the power of 5 should be raised to the power of 5. So first 4 to the power of 5, and then times p to the power of 5 to the power of 5. Numerator stays the same. 4 to the power of 5, thought it was 1024, but I might be mistaken. And p to the power of 5 raised to the power of 5 is p to the power of 25, because I can multiply the exponents by each other if I raise a power to another power. This is the shortest way to write this down. Let's look at exercise 46b. Here we get a formula. That's a division or a fraction, but we can write this a lot shorter. Our job is to write it as y equals a times x to the power of n. Let's start in the numerator and work out the things that we can. First, in the middle, I can raise 5 to the power of 2, and I can do the same with x. So I get 8x to the power of 3 times 25 x squared. Mind you, here we don't have to raise 8 to the power of 3 because there's no brackets around 8x like there is around 5x. So here the 3 only belongs to the x. The square here is for the whole product of 5x. Don't forget the last factor, x squared. And let's look at the denominator, 2x squared to the power of 2. Here I need to square both 2 and x squared. 2 squared is of course 4. X squared squared is x to the power of 4. In the numerator I can now calculate the 3 factors by first doing the regular numbers. So 8 times 25 is 200, I think so. And x to the power of 3 times x squared again is x to the power of 7, because when you multiply powers with the same base, then you can add up the exponents, and 3 plus 2 plus 2 is 7. Copy down the denominator, 4x to the power of 4. And now we can divide this. First the regular numbers. 200 divided by 4 is 50. And x to the power of 7 divided by x to the power of 4 is x to the power of 3. Because when you divide powers by each other that have the same base, then you can subtract the exponents from each other. So our final answer is 50 x to the power of 3. Let's write it as a formula again. So y equals 50 x to the power of 3. This is our final answer in the shape that they would want it. The value for a is 50 and the value for n is 3. A similar exercise in 46D. Let's start here. First copy down the rest. So 8x to the power of 5 plus 2x times. Now a power raised to the power means multiplying the exponents. So x to the power of 4. And then I can copy down the denominator. Nothing much happens there. Right, in the numerator I have both plus and times. Times goes first, so copy down 8x to the power of 5. And then I calculate this. 2x times x to the power of 4 is 2x to the power of 5. Because I can add up the exponents here, and the hidden exponent here is the exponent 1. And this needs to be divided by 5x to the power of 3. Now, in the numerator, I have two like terms. Both have the same variable and the same exponent. That means I can add up 8 and 2, so I get 10x to the power of 5. And I still have 5x to the power of 3 in the denominator. And now I can divide. 10 divided by 5 is 2. And x to the power of 5 divided by x to the power of 3 is x to the power of 2, or x squared. So this is the final answer. Let's copy it down with the y squared in front of it. So our final answer becomes y equals 2x squared. That's it. In exercise 48, the difference is indicated by adding and multiplying between the brackets. Let's quickly look at the theory right above it. Here we see two formulas that look quite similar. The only difference is that here between the brackets we have a product, a multiplication, 5 times x, and here between the brackets we have a sum, 5 plus x. Both things need to be squared. If you have to write these things without brackets, then this is done with the rule that we have learned in this section, by squaring both 5 and x. The final answer becomes 25x squared. But if there's a plus in between, then you cannot use this rule. Then you can interpret this as 5 plus x multiplied by itself. So again, a second pair of brackets with 5 plus x between it. And then you just have to remove the brackets, either with the multiplication table, the way the book does it, or with the arcs that I usually use. I'll show you an example of the arcs here in 48G. So like I said, here we are not allowed to square minus 5 and 4x because there's a plus here. If this had been a multiplication, then we could have done that. But right now we have to remove brackets. Squaring means multiplying by itself, so actually what we have here is this. Now the book uses the multiplication table. I usually use arcs to remove brackets. So these are the 4 arcs that you have to draw. Each arc represents a multiplication. So here we go. Minus 5 times minus 5, that's 25. Minus 5 times 4x is minus 20x. 4x times minus 5 is again minus 20x. And the last one, 4x times 4x, is positive 16x squared. This can be written shorter. I start with the highest power, so 16x squared in the front. These two can be collected together and becomes minus 40x. And the last term is plus 25, which I write at the end. So this is the first formula written without brackets. That's all you need to know for section 9.6, calculating with powers.